5.5, graphs of proportional relationships. This section has a lot of information in it, so definitely watch it, listen to it again, write your notes and do the practice problems, but we will also be going over this in detail in class. Okay, we are given a ratio table and we want to see if the ratios form a proportional relationship. The way we remember to do that is to find the value of the ratios, right? And to find the value of the ratios of tomatoes to cucumbers, remember from last couple of sections, it was the first one over the second one. So tomatoes over cucumbers will give us the value of the ratio. So 2 over 1 is 2, 4 over 2 is also 2, and 6 over 3 is 2. All these ratios have the same value, 2, and so they are equivalent and they form a proportional relationship. We can also use a graph, though, to determine if ratios form a proportional relationship. Okay, so we need to graph them. This ratio table, we want to put it onto the coordinate plane. Remember, x-axis goes this way, y-axis goes this way. Okay, so in this, we are told what our x and y are. We're told that x is cucumbers, y is tomatoes. So let's look at plotting this. Okay, so x is 1, y is 2, x is 2, y is 4, x is 3, 3 cucumbers, 6 tomatoes. Let's connect the dots. If we were to connect the dots in a nice way, using a ruler, you would see that this line forms a nice straight line and it passes through the origin. The origin, remember, is the point 0, 0. It's where the x-axis and y-axis intersect. So the ratios in this table form a proportional relationship because it creates a line and the line goes through the origin. This line can be expressed by this equation, y equals kx. Remember, k is the same as the value of the ratio, and it has a formal name of constant of proportionality. Okay? Let's do 2 examples and see if these ratios form a proportional relationship. So let's look at this first one. Let's graph it. X is 0, y is negative 2. X is 1, y is 1. X is 2 and 4, 3 and 7. We can connect the dots and we see it forms a line. Line, yes. Origin, no. So this does not form a proportional relationship. Let's look at this one and let's graph it. 0, 0, 3, 1, 6 and 2, 9 and 3. Draw a line. It forms a line and the line passes through 0, 0. So this does form a proportional relationship. What is our K? What is our constant of proportionality? What is our value of the relationship, of the ratio? Remember, y to x, y over x, right? This is what we want. This is what we want. So y, 1 over 3. That is our k, our y over our x. And if you notice, if you put y over x, y over x, y over x, they all have a constant of proportionality. Their value of their ratios are all the same, and it equals 1/3. Okay, time for you to write in your notes. There is the top section where you have a bunch of fill in the blanks and a graph. And I would like for you to draw an example, your own example of a proportional relationship. Make sure it goes through the point 0, 0, and it is a straight line. Okay, now that you're done with that, we are going to find unit rate from a graph. And to do that, we're going to look at an example. In this example, we have a graph of the speed of a subway car. And we want to find the speed in miles per minute. Remember, unit rate is a number per one, right? Miles. How many miles per 1 minute? Okay, so let's look at this. It forms a line. Our data forms a line and it passes through the point 0, 0, so we know that it is a proportional relationship. So there are two ways to do this. Let's look at point 2, 1. Okay, right there. That tells us in 2 minutes, our subway car travels a distance of 1 mile. Okay, to find the unit rate, remember, we need to have a 1 on the bottom, right? A 1 on the bottom, just like this. So if we have a 1 on the bottom, if our x equals 1, then we need to divide both the top and bottom by 2. So that gives us 1/2 mile per 1 minute, and that's our unit rate. Another way to do it would be to find, we know we want 1 on the bottom and the number on top, right? Which is the same as this. So we want our x value to be 1. So over here, we need to find the 1. Here it is. Let's go up and let's look, find the corresponding value on the y-axis, and that's 1/2. So when we have 1 minute, we have 1/2 mile. So again, this one also shows us that our unit rate is 1/2 mile in 1 minute. Okay, another example. We have a robotic vacuum that cleans in X minutes. Cleans an area in square feet. And we want to find how much it cleaned in 10 minutes. In order for us to figure that out, we need to find out how much the robot cleans in 1 minute, right? The unit rate. Okay. From the slide before, we know that we want 1 on the bottom to find the unit rate, meaning we want our x to equal 1, right? If our x is 1, then the corresponding y value is going to be our unit rate. So let's look over here. Here's our x. Let's go up, and our y equals what? 16. So our unit rate is 16 square feet in 1 minute. Okay, in order to find how much it cleaned in 10 minutes, let's multiply both the top and bottom by 10, because that's 10 minutes, right? So 160 times 10 is 16 times 10 is 160. It cleans 160 square feet in 10 minutes. Now, if we wanted to write this relationship, this into an equation of a line, we can do that easily by, all we have to do is do y and x, but we need to fill in the k. What do we find the k? Remember, k is the same as your value of the ratio. It's also the same as your unit rate, right? So we found our unit rate, 16 square feet per minute. So in the box goes 16. So our equation actually is y equals 16x, meaning if we wanted to know 10 minutes, right? So if we plugged in x equals 10, that would give us 160. We could find the answer. If we wanted to know 1,000 minutes, we'd be able to tell you how much the robotic vacuum could clean by calculating it with this equation. Okay, now it is time for you to write in your notes. There's just 3 little fill in the blanks. And time to do practice problems. There's 1, 2, 3. Okay, practice problem number 1. There are 2 ratio tables. In each ratio table, you needed to plot the points on the graph and determine whether or not x and y are proportional. So let's run through the first one. Let's plot the points. Okay, plot the points. Draw our line. Forms a line, yes? Yes. Passes through the origin. If it does, then it's proportional. If it doesn't, then it's not. Okay, let's look at our second one. Let's plot these. 2,4, 3,6. Okay, this blue one forms a line, yes? Yes. Passes through the origin. That is what you need to determine. If it passes through the origin, then yes, it is proportional. If not, then no, it is not proportional. Okay, practice problem number 2. We need to identify the unit rate and determine how much 1 pound of apples cost. So the unit rate, remember, one way is we want the x to be 1. To find where x is 1, and we'll find our corresponding y value, right? Which is the same as this, which is the same as this. Okay, so 1, go up, our y value is 1.5. So we know our unit rate is $1.5 per 1 pound. So that's our unit rate. Okay. Okay, another way to do it though would be as if you, let's say there was no point that we could easily determine at x equals 1 and we had to use the point x equals 3 up here. Well, that tells us that it costs us $4.50 for 3 pounds. How do we find the unit rate when we're given something like this? We divide the top and bottom by 3, or you divide just the top by the bottom, which is the same thing. And we also find it is $1.5 per pound. Okay, I pretty much did that one for you, but that was kind of a tricky one. And practice problem number 3, tell whether x and y are proportional. Okay, remember our equation of proportionality is y equals kx, where k is the constant of proportionality, which is also the same as the value of our ratio, which is the same as what? Unit rate. So we want to get this equation here into this form here. So we want the y on one side, the x on the other, and we need some number here. What number goes there? What number is there? And that is your k. That is your constant of proportionality. But you also need to determine if you can put it into this form. If it can go into this form, then yes, it's proportional and your k equals something. And that is the end of 5.5.